Okay, how does Java achieve high performance? It can be achieved through different strategies such as just-in-time compiler, memory management, efficient runtime execution. So, for example, just-in-time compilation, we have mentioned it before that it makes sure that if like there is some kind of hotspot, like frequent usage of some methods, it's gonna be converted into native code, which is gonna be saved in memory in order to be optimized while being executed. So this makes sure that Java run faster um, as they run here. So also we have garbage collection, which is amazing in order that we don't really care much about how we clean up the memory, as garbage collection makes this kind of thing as a black box to us. We have also different algorithms that being used that you might need some tweaks if you want to optimize it even more, the memory management stuff using this garbage collection. Also this kind of I'm not gonna say preventing memory leaks. You can have memory leaks if you're a bad developer and don't know what you're doing. So you really need to pay much attention to the memory leak stuff and fragmentation. Okay, so the Java virtual machine also provides automatic heap management, which dynamically allocates and deallocates memory. So Java's automatic garbage collection helps to manage large application, of course, without really needing to have like this kind of pointer and this kind of stuff that's being available in C and C++ kind of stuff. Of course, the Java supports multi-threading and concurrency if you want to make use of the many cores that you have and many threads in order to have some kind of parallelism that's happening altogether. There are also some libraries that are being used which is highly optimized, such as the standard library, which is utility, which I've just seen like list and hash map and this kind of stuff. Also, it's a platform independent. So basically, each Java virtual machine that run on its own machine kind of knows the ins and out of that internal operating system that's going to be used. So maybe it's going to be trying to make it more efficient when it works for that specific independent platform. So yeah, this is like the way I'm thinking about Java. Also, there are another way, like I hadn't really encountered it, but while searching, I found out it's available, which is Java native interface, which is when you're trying to use native code, which is C++ or C. This allows to call high performance native code, and you can use it like something like this native keywords, which is like here, and when you call like some kind of library, which is basically you're loading some library here, and basically now you have this internal usage of this native code which is written in C++, which is more faster than the high level language which we are going to be using, which is Java.